Hello dear friends, I welcome you all for the lecture number 8 on this Hammett linear free energy relationship. In this lecture we will discuss about the second example of concave upward deviation. The second example of this concave upward deviation is the acetolysis of a 3-aryl-2-butyl brosylate. Here is the reaction. Here simple the acetolysis of 3-aryl 2-butyl brosylate is taking place, and the rho value for this reaction is negative, that is small negative rho value. Now this small negative rho value, now this reaction is nucleophilic substitution reaction. Nucleophilic substitution reaction. Substitution reaction. So here the breaking of carbon COBS bond will take place and formation of CO COAC bond will take place. Now, as we have the negative rho value, it means that the electron density at reaction center is going away, going away from the reaction center. Okay. So here this carbon is a reaction center where the reaction is taking place, and as we have the negative rho value, it means the formation of COAC bond and breaking of COBS bond. Among these, the breaking of COBS bond is taking place first, and then formation of COBS bond is started. So breaking of COBS bond is started, and then formation of COAC bond is take place, as we have a negative rho value, as we have a small negative rho value. So this is about the rho value of this reaction. Now we will consider when this we will study, or we will discuss that when this X is changes from the strong electron withdrawing group to strong electron donating group. Then the graph shows that here we have a rate constant, and on this axis we have a substituent constant. Now as we move from the right to left side, then mm, we have a straight line plot for the uh, up to the meta substituted chlorine at a meta position. But as we move from the metachloro to parachloro, the slight deviation is started. Slight deviation from the straight line is started, and this deviation um, become larger when the strong electron donating group is there. They expected we are expecting over here straight line relationship, but there is a deviation is appear. Deviation is take place from these two stronger to the stronger electron donating group. Now the explanation for this explanation for this deviation from the straight line is changing in mechanism. There is a change in mechanism is take place. Change in mechanism is take place as we move from strong electron withdrawing group to strong electron donating group. Now, why this is now the what is the possibility of the mechanism change? Then here two types of mechanisms are possible. When strong electron donating or moderate electron withdrawing group is there, in that case the electron density of this pH ring is withdrawn by this X group, and in such a cases this the external nucleophile attack on a carbon bonded to living group, and the mechanism of such a kind of reaction follow the SN2 mechanism. But when substituted X, when substituted X is a strong electron donating, then it increases the electron density of this pH ring, and this pH ring participate in the departure of the leaving group, and participate the departure of leaving group, and NGP type of mechanism take place. NGP type of mechanism is take place. NGP means neighboring group participation, or you can say the internal nucleophilic substitution. Internal nucleophilic substitution. And so here this, if we consider the O-methoxy group, methoxy group, then this methoxy group donate the electron density to this pH, and this pH is involved in the departure of this leaving group. Now, why the rate of such a kind of reaction is exceptionally faster? Here, you can say that you can see that the rate of this substituent, the rate of these substituents is increased, and therefore they are appear out of line. The why? What is the reason behind this? That the rate of such a reaction is, why the rate of such a reaction is faster? Because in this case, the internal nucleophile is involved is involved involved in the departure of leaving group, and departure of leaving group. Internal nucleophile is involved in the departure of leaving group, and this internal nucleophile, due to its close proximity, it attacks with faster rate on this carbon. Also also due to this, the step of ionization become faster become faster, and as the molecule is ionized ionized the external nucleophile, it become easy for the external nucleophile to attack on this on such a ionized species, and therefore the such a kind of reactions, that is the reaction with NGP type of mechanism, reaction having the or reaction following the NGP type of mechanism, have the faster rate, or the rate of such a reaction is exceptionally faster, while the reaction those following the asymptotic mechanism, then such a kind of mechanism having the normal rate of reaction for such a SN2 kind of mechanism is normal, but when NGP mechanism is there, the rate is exceptionally faster. I am again repeating why the rate of such a reaction is faster, because this internal nucleophile involve or show the strong enzymatic assistance for the departure of this living group, and as this OBS is departed, the species become ionized, and therefore the extracted now become very easy to attack the external nucleophile, and therefore rate of reaction is increases. Now, what is the evidences for this? That some reactions are following SN2 mechanism, and some reactions are following the NGP mechanism. Now, what is the evidence for this? So, the evidence for this is the stereochemistry of the product. When reaction follow the SN2 mechanism, in that case, and if we have a 3O compound, then this 3O compound will offer the erythro product if reaction is taking place via SN2 mechanism. And if we start with 3O reactant, 3O isomer, and if reaction is following the NGP mechanism, In such a cases, in such a cases, in such a cases, we have a 3O product. That is retention of configuration is take place. That is retention of configuration is take place. While in case of SN2 mechanism, there is a inversion of mechanism is taking place. Now, why there is a retention in configuration in case of NGP mechanism? Because NGP mechanism involves two subsequent SN2 mechanism. This is the here this internal nucleophile approaches from opposite side, that is back side. So this is first SN2 reaction, and say this is your second SN2 reaction, and the result of inversion of pre-inversion is a retention. And this stereochemical evidences, stereochemical results is a uh, is it shows that there some reactions follow the SN2 mechanism and some reactions are follow the NGP mechanism. Now, when SN2 mechanism are possible, when there is this X is a strong electron withdrawing, that withdraw the electron density of pH ring, and therefore pH ring is unable to show the enantiomeric assistance in the departure of leaving group, or this pH group is now unable to attack on the carbon bonded to OBS. But at the same time, when that X is not electron withdrawing, in that case, or strong electron donating, in that case the pH ring become electron rich, and this pi electron density is now attack over here on the carbon bonded to OBS. In this way, some reactions are showing in SN2 mechanism and some are showing the NGP mechanism. The reaction or a substituent that follows the SN2 mechanism, in that case we have a inversion of configuration. Inversion in product is found, and when the reaction follow the NGP mechanism, in this case the 3O compound offer 3O product, that is retention of configuration is take place. So this is all about the concave upward deviation. This is all about the example of concave upward deviation of which is shown by the acetolysis of 3-aryl 2-butyl brosylate. So again, again we can make a statement that concave upward deviation, whenever there is a concave upward deviation, it indicates that there is a change in mechanism of reaction. So these groups these groups are showing SN2 mechanism, and from metachloro to paramethoxy, they shows NGP mechanism. And as the rate of NGP mechanism is very much faster or is exceptionally faster, and therefore these substituents are now appear out of line as the rate of reaction is exceptionally increases, and therefore this straight line from here the rate of reaction is exceptionally increases, and therefore that straight line become deviate. Deviation in straight line is appear. So this is the evidences, stereochemical evidences for the NGP mechanism. When paramethoxy group is there, we have a 100% 3O product from the 3O reactant. When paramethyl group is there, we have a 88% of the 3O product from the 3O reactant. While the 12% of molecule is showing the SN2 mechanism. And in this way, as we go from strong electron donating group to strong electron withdrawing group, the percent of NGP mechanism decreases and percent of SN2 mechanism increases. And therefore, for the paranitro and meta CF3 group, Both are strong electron withdrawing group, and therefore formation of 3O product and 3O product is almost zero, and we have a uh, erythroproduct erythroproduct from 3O, that is SN2 mechanism with inversion of configuration. Okay, thank you.